Question 4. So this is about functional groups that you've not seen. They can do this, are allowed to do this. So this is really, when you see something like this, they're going to be applying some other knowledge that you might have. And it's quite often about mechanisms and knowledge of mechanisms. So these are ethers. I tell you that they are ROH. Here's a couple of structures here. So you're looking at this saying that this is ethane, because this is your longest chain, and it's methoxy. So they're telling you that the methoxy is about that bit. This is saying that your longest chain is propane. So there's your longest chain of propane, and you are linking on in the 2 position to it with an ethoxy, 1, 2, an ethoxy unit. So there's a lot of processing to do that. Taking a look then at the skeletal formula of 2-ethoxymethyl butane. So you need to do methyl butane. So 1, 2, 3, 4. You have got a 2 position where it's joining on, and you've got a 3 position with the methyl on it there, and then it's ethoxy where it's joining on there. So they tell you that they're prepared by nucleophilic substitution of haloalkanes with alkoxide ions. So they tell you what an alkoxide ion looks like. That they can be prepared by reacting sodium with an alcohol, and that a gas is formed. So these are, this is my ROH, but I've lost my hydrogen from it. So if that is pulling off, this is behaving like an acid in this particular case. So what we're looking at is we've got metal plus acid here. So you're making methoxide ions. You've got 2 sodiums, so this is your salt, and this is the hydrogen that's going to be formed. So you've got metal plus acid is making a salt and hydrogen here. So very, very difficult bits of application of knowledge at the end of this paper just here. However, this becomes a little easier at this point. So the methoxyethane shown in figure 4.1 can be prepared by reacting bromoethane with methoxide ions. Suggest the mechanism. Yeah, so you're using that and you're using that. So here's my molecule. If you want to, you can write this out as CH3CBr. Yep, so you can do it either way if you want to. So having got it here, oops, Daisy, I've missed an oxygen out of there. So you've got CH3O with a minus charge on it, and then that minus charge is going to behave as the nucleophile here. So that will come into that delta plus, which should be labelled, and then that bond will break and go onto my Br minus, and then I make this. So when you start this off, we should be setting out what you start with there, and what you start with over there. So you're sort of looking to see what you get on this side compared to that side. So if you prefer this side, you could have put CH2O, CH3. It's up to you, but it might have made it easier to see where you were going for. And you've got the Br minus after it. In the mechanism, it acts as a nucleophile, even if you haven't understood anything else up here. You know, if something is acting as a nucleophile, that is because it is donating an electron pair. Yeah. And the bond fission has to be heterolytic because we've got plus and minus charges, or in your head it might just be because it is not a radical substitution. Yeah, so radical substitutions have homolytic all the other ones have heterolytic. So this one should be that. So you need both of those parts to be able to get that. I'm not going to look at this one because at the time when we were doing this paper, we had not done NMR, so I'm going to leave that one out. And the final part of this paper is all the mechanisms here. So I'm going to highlight over here. Once again, this is answers, so you shouldn't actually highlight yourself, but because I've pre-written it, I shall highlight it. So we've got the alkoxide ions can also act as a base if the diagram shows an incomplete mechanism for the reaction. And then an intermediate reacting. Step 1, add curly arrows to show how that reacts with the diester to form this intermediate, and then show what you get at the end. So in these mechanisms, you need to look at where you start and where you end. And what you need to be looking at is the fact that over here, we've no longer got this hydrogen attached. We've got a minus there instead. Okay, so what's happening here is that this is coming in and it's acting as a base, which is just written up there, and it's accepting that hydrogen there, and then those, so that's disappeared because it's gone over to there, and then this, yeah, is dropping down that lone pair there onto that one. And then you've got to get from you've now got this, and you've got this substance here. Yeah, so this substance here is CH3, CH2, Br. You've got a delta minus, you've got a delta plus, and here you've got a nucleophile. You've got a minus charge. So that minus charge here is going to come in to there, and it's going to kick that out over there. Which means that when you draw this structure, everything else is going to stay the same. All you're going to do is add that onto there. And final one, nice and easy. So don't give up ever on these. There's always an easy one somewhere sitting amongst all of this difficult stuff. Explain how it acts as a base. Anything acting a base is accepting a proton.